Chapter 1. The Impossible Result. 100,000 watts. Aimed at nothing. Every scientist held their breath, waiting 37 hours for a single whisper from 12 billion miles away. Voyager 2 had gone silent. But the loudest thing about that spacecraft was never its signal. It was the silence in what it already sent back. August 2nd, 2023. A radio dish in Canberra, Australia, Deep Space Station 43, 70 meters wide, fires the most powerful command in NASA's arsenal at a spacecraft that has been effectively deaf for 2 weeks. Someone on the ground had sent the wrong instruction back in July. 2 degrees. That was all it took. Voyager 2's antenna slipped 2 degrees off Earth, and 12 billion miles of empty space swallowed it whole. The shout works. On August 4th, telemetry starts flowing again. The headlines celebrate. The engineers exhale. And that should be the end of the story. It isn't. Because while the world was watching Canberra fight to restore Voyager 2's voice, a smaller group of scientists was already staring at what Voyager 2 had said 34 years earlier, and admitting, quietly, that they still didn't understand it. I want you to hold this in your head. 2 silences, 1 radio, 1 scientific, and the second one is far more disturbing than the first. Rewind to August 25th, 1989. Voyager 2 sweeps past Neptune at just 5,000 kilometers above the cloud tops, the closest any human machine has ever come to the last giant planet. It has only a few hours. It sends everything it can. Then it's gone, hurtling toward interstellar space, and nothing has been back to Neptune since. Here's what everyone expected to find. By 1989, planetary science had a model of magnetic fields it trusted absolutely. Every planet with a large enough conducting interior, molten iron in Earth's case, metallic hydrogen in Jupiter's, should generate a magnetic field by convection. Currents spin deep inside, and the field they produce lines up almost perfectly with the planet's rotation axis. Earth's magnetic pole sits just 11 degrees from geographic north, Jupiter's 10, Saturn's less than 1. This wasn't a guess. It was the pattern of a solved problem. Voyager 2's magnetometer switched on as it entered Neptune's magnetosphere, and it recorded something that pattern could not explain. Neptune's magnetic field is tilted 47 degrees off its rotation axis. Read that again. Not 11, not 5, 47. And it gets stranger. The center of that field, the point the entire dynamo appears to spin around, isn't at the center of the planet. It's offset by 55% of Neptune's radius, more than half. I want you to picture what that means. Take Earth. Move the North Pole from the Arctic down to Brazil. Then take the entire magnetic engine that generates our field and bury it 3,000 kilometers beneath Australia. Every compass on the planet goes insane. Ships lose north. GPS starts drifting. That is what a compass would do on Neptune. There is no north. The needle sweeps around the planet as it rotates, tracing a corkscrew through space. Now, the responsible question, the one every real scientist asked first. Could this be an error? Voyager 2 had 1 shot at Neptune. A flyby is a snapshot. Snapshots lie sometimes, so a team led by Norman Ness and Mario Acuna at NASA's Goddard Space Flight Center pulled the raw magnetometer data apart, hour by hour. They fit a model called the Offset Tilted Dipole, the OTD, designed to test exactly this, whether a strange geometry recorded from a single trajectory could just be a bad fit to a normal field. If the numbers really pointed to an ordinary dynamo tilted by coincidence, the OTD would show it. The OTD didn't show that. The OTD confirmed it. Between 4 and 15 Neptune radii out, the field really was that broken, tilted 47 degrees, offset by 0.55 planetary radii. not an artifact, not a bad model. Real geometry, sitting there in the data. The mystery survived its first honest test, and here is the detail that refuses to fit. Inside 4 Neptune radii, closer to the planet than the OTD model can trust itself, the field falls apart even more. It stops looking like a single tilted dipole. It starts looking like something with multiple offset centers. Higher order magnetic structure the equation cannot describe cleanly, which means the dynamo generating Neptune's field is not at Neptune's center. It is shallow. It is somewhere near the surface. It is running from a place it is not supposed to be running from at all. Which forces one impossible question. If Neptune's magnetic engine isn't where every accepted theory in 1989 said it should be, then where is it? What is it made of? And why did it take almost 40 years for anyone to admit we still don't know? Chapter 2. The explanations begin to fail. If the dynamo isn't at Neptune's center, then it has to be somewhere else. And that somewhere else changes everything we thought we knew about how ice giants work. For 15 years after Voyager 2, the leading answer sat in a paper by Sabine Stanley and Jeremy Bloxham, published in 2004. Their idea was almost simple. Forget the deep, hot iron core that runs Earth's dynamo. Neptune doesn't have one. What Neptune has, beneath its atmosphere, is an ocean, but not a water ocean the way you picture the Pacific. It's a scalding high-pressure fluid of water, ammonia, and methane, compressed until it becomes electrically conductive. And Stanley and Bloxham argued the dynamo doesn't happen throughout that whole ocean. It happens in a thin, unstable shell inside it. Here's why that matters. When you run the equations for a dynamo confined to a thin shell, rather than a deep core, the field it produces is not neat. It is not aligned. It is chaotic, tilted, offset, riddled with higher-order structure. Exactly what Voyager 2 saw. And for a moment, the mystery starts to shrink. Because if Stanley and Bloxham are right, Neptune's field isn't broken. It's the natural result of a dynamo running in the wrong place. The 47 degrees, the 0.55 offset, the multipole chaos inside 4 planetary radii. All of it becomes not an anomaly, but a signature. The thin shell explains everything Chapter 1 refused to explain. But there's a problem, and it's a big one. The Stanley-Bloxham model needs the fluid inside that shell to behave in a very specific way. It needs a rheology, a set of flow properties, viscosity, conductivity, stability, that nobody had ever produced in a laboratory. For 20 years, that hypothesis sat in the literature as the best available guess, backed by simulations, unsupported by any direct experimental evidence that the material inside Neptune actually does what the theory needs it to do. Then, in February 2026, that changed. An international team pushed pure water inside a diamond anvil cell, 2 microscopic diamond tips squeezing a sample harder than anything else on Earth can squeeze. They took ordinary H2O to 1.5 million times atmospheric pressure. Then they heated it to 2500 Kelvin, conditions that only exist naturally in one place we know of, the interiors of ice giants. And the water became something new. The oxygen atoms locked into a solid crystal lattice, but the hydrogen, the protons, tore free and started flowing through that lattice like an electric current through wire, solid and liquid at the same time, neither and both, a phase of matter called superionic water. And the crucial finding, published in Nature by senior scientist Ariana Gleason and her team, wasn't just that it exists. It was that its lattice is imperfect, defective, riddled with stacking faults and irregular structure that make its electrical currents equally irregular, chaotic, multipolar. Now look back at Chapter 1. Remember the detail that refused to fit? The one where the OTD model works out beyond 4 Neptune radii, but collapses closer in, where the field starts requiring higher-order multipole structure that nothing sensible could explain? That's exactly what a defect-riddled supersonic layer would produce. For the first time since 1989, we have a physical mechanism, actual measured material behavior, not just simulation, that explains why Neptune's dynamo is shallow, tilted, and offset. The mystery has an answer, or at least the beginning of one. But now watch what happens next. In May 2026, the James Webb Space Telescope pointed its infrared spectrometer at Neptune and finally caught something Voyager 2 had only glimpsed: hydrogen trihydride ions, H3+, glowing in Neptune's upper atmosphere, auroras, and they were exactly where the tilted, offset field predicts they should be, not at the poles, at the mid-latitudes. Everywhere previous searches from Earth had refused to look because they assumed Neptune's aurorae would behave like everyone else's. Confirmation. But JWST measured something else at the same time. Neptune's upper atmosphere is now several hundred Kelvin cooler than it was in 1989. Cooler, in 35 years, on a planet. Which means Voyager 2's data wasn't a snapshot of a static world. It was one frame of a changing one. The field itself may drift. The atmosphere is drifting. Everything we built from 6 hours of 1989 data may already be out of date. And this is where the story turns. Because as unsettling as everything I've just told you is, the sideways field, the supersonic ocean, the drifting atmosphere, none of it is the strangest thing Voyager 2 recovered from the Neptune system. Neptune wasn't the anomaly. Neptune's moon was. Voyager 2 spent its final hours before leaving the solar system, taking pictures of a small, frozen world orbiting Neptune backwards, retrograde, against the spin of everything around it, a world every model in 1989 said should be geologically dead, a shard of the Kuiper Belt, captured billions of years ago, cooled to the temperature of interstellar space, silent forever. Its name is Triton, and in June 2026, 3 researchers published a paper suggesting Triton is not dead at all. Chapter 3. What the mystery actually means. The paper is called A Modern Dynamo at Triton as a consequence of its capture by Neptune. It ran in Nature Astronomy in June 2026. The authors, Lana Tilke, Kevin Trin, and Joseph O'Rourke at Arizona State, didn't send a spacecraft. They didn't need to. They ran the thermal history of a moon backwards. Here's what they found. When Triton was captured by Neptune, pulled out of a trans-Neptunian binary billions of years ago, dragged into a wildly elongated orbit around a giant it had never met, it didn't just drift into place. Its orbit had to circularize. Every long, stretched pass around Neptune got squeezed by tidal forces into a rounder loop, and every squeeze released energy, enormous amounts of it, enough according to the Tilke model to melt Triton from the inside out, melted enough to differentiate, enough to separate the rock and iron from the ice, enough to pull the heavy metallic material down through the moon's interior and pool it into a genuine metallic core. A captured Kuiper Belt object, made of the same material as Pluto, ended up with the internal architecture of a small planet. And here is where the model gets dangerous. Because if the core is still warm, and Tilke and her co-authors argue it is, then iron sulfide is currently crystallizing from the top of that core downward, releasing lighter material that rises, driving compositional convection. And compositional convection driving liquid metal produces the same thing it produces on Earth, a magnetic field. Their nominal model predicts a surface field strength of roughly 1 microtesla. That's tiny, about 1/50th of Earth's. But it isn't zero, and it isn't decorative. It is a functioning dynamo, running right now, inside a moon nobody expected to be alive. I want to be honest with you about what this is and what it isn't. This is a prediction, not a measurement. Nobody has directly detected Triton's magnetic field. Voyager 2 came close enough to the Neptune system to give us everything we know about the planet, but at Triton, it flew 40,000 kilometers overhead. Too far, too fast. A 1 microtesla field at that range is invisible to a magnetometer designed for Neptune. The signal, if it exists, was there. Voyager 2 just wasn't close enough to hear it. So the honest answer is this. We have a model, backed by lab thermodynamics and the entire physics of tidal heating, that says Triton should be running a dynamo, and we have no direct evidence to confirm or reject it. Until we go back, we don't know. But think about what it would mean if it's real. Consequence 1. Triton would join Ganymede as one of the only known moons in the solar system with an active magnetic engine, and it would be the only captured body known to run one. A trans-Neptunian refugee, generating its own field, billions of years after every model said it should have gone cold. Consequence 2, and this is the strangest one, it would break the plan for finding Triton's ocean. Under the ice, Triton is thought to have liquid water. Every proposed future mission to Neptune, every flagship concept NASA and ESA have sketched, plans to confirm that ocean using a technique called magnetic induction. You measure how Neptune's field distorts as it passes through Triton. If there's a conductive ocean underneath the ice, the field bends in a specific way. It's a beautiful trick. It's how we know Europa has an ocean. It's how we know Ganymede does. It doesn't work if Triton has a field of its own. The moon's own signature swamps the signal. The technique that was supposed to answer humanity's next great question about a possibly habitable world is quietly being canceled by physics we didn't know existed, and consequence 3 is the one you should sit with. A body that shouldn't have been captured got captured. A body that shouldn't have differentiated differentiated. A body that shouldn't have a core formed one. A body that shouldn't be geologically alive may still be running an engine 4.5 billion years after it should have gone cold. The outer solar system does not respect the words dead and alive. Now hold the compass in your mind one more time. At Neptune, it swings 47 degrees off, pointing sideways at a shallow shell of superionic water we can only just now make in a laboratory. At Triton, in the model that may or may not be true, the needle flickers, which brings us back, finally, to the shout. When Canberra fired 100,000 watts into empty space in August 2023, everyone thought they were rescuing a spacecraft. They were. But the deeper silence Voyager 2 has been keeping isn't in its antenna. It's in 6 hours of data from 1989 that took 34 years, a superionic water experiment, an infrared telescope 1 million miles from Earth, and a thermal evolution model of a captured moon to even begin to decode. NASA didn't recover alien technology. They didn't recover a broken law of physics. What they recovered was worse in a way, and better in another. They recovered evidence that our best theories in 1989 were describing a solar system simpler than the one that actually exists. A planet whose magnetic engine sits in the wrong place, made of matter we barely understand. A moon that was supposed to be a fossil and may still be a furnace. Which leaves one last question. The one every planetary scientist working on the outer solar system is quietly asking now. If Triton, a body no one expected to be alive, is running its own dynamo, how many other captured worlds in Neptune's system, in the Kuiper Belt, around other stars, are running engines we simply haven't looked for? Voyager 2 flew past Neptune once, in 1989. Nothing has been back since. and what it left behind still isn't finished speaking.